So today we are solving a question sort an array of 0, 1, 2. So let's discuss what the question saying is. So suppose there is an array 0, 1, 2, 0, 1, 2, 1, 2, 0, 0, 0, 1. So this is an array which we have been given in the question, and the question says that we have to sort this array, um, and all the zeros come together and all the one come together and all the two come together. Basically this is a question derived from a sort an array based on the colors red, green, blue. So all the red color balls come together and all the green balls come together and all the blue balls come together. So this question is derived from this. So now we have to solve this question. So there are many approaches for solving this question. First approach, let's discuss about the first approach, that is the brute force. Clearly we can see that we have to sort this array. So we can sort this array and that will be our answer. So 0, 0, 0, 1, 1, then 2. So let's discuss about the time complexity of this. The time complexity of this will be big O of n log n. If we will use heap if we will use if we will use merge sort, so the time complexity will be big of n log n and the space complexity of big O of n. So this is a very simple approach, brute force, by just sorting the given array and we will get our answer. So let's move on to the next approach of this question. We want to reduce this n log n time to less than n log n. So we will solve this question by another method. So another method can be, we can use three pointers, count 1, count 2 and count 0, 1 and 2. Basically what we are doing in this question, let's count number of zeros in the given array. Let's and then count number of 1 given in the array and count number of 2 given in the array. And we got the counts of 0, 1, 2, and starting from the array we will put 0 as per the count, then 1 as per the count of 1, and then 2 as per the count of 2. So the time complexity of this approach will be less than n log n time. So for how we can calculate the time complexity of this question. So for counting 0, number of 0, number of 1, number of 2, we need to iterate the given array only once. So the time complexity for iterating will be big O of n. And for again we need to iterate the given array to put 0, 1, 2 based on their counts. So for that we are again requiring big O of n. So the total time complexity will be big O of 2n. And the space complexity, this is the time complexity, and space complexity we go 1 as we are not using any extra space, that's why these are the complexities. So this is also the easy approach for doing the question, just by counting the number of 0, 1 and 2 and putting putting the 0, 1, 2 based on their counts. So let's write the code for this part, pseudo code. So count of 0, 1, 2, we will be running a loop for I is equal to 0 to n, and checking if a of I is equal to 0, then we will increase the count for 0. If a of I is equal to 1, then we will increase the count of 1. If a of I is 2, then increase the count of 2. So in this loop we get all the counts of 0, 1 and 2. In this loop we got the count of 0, 1, 2. Now place the 0, 1, 2 in the array based on the count of 0, 1, 2 for I is equal to 0 to n. No, for I is equal to not n. For I is equal to 0, I less than count of 0 and plus I. So just arr I is equal to 0. Then this is for 0. Now we will putting the count from 0 to count 0. From 0 to count 0 we have put 0 in the array. Now from count to count 1 we will be putting 1. So from I is equal to cnt 0, I less than cnt 1 and plus I. Again we are doing the same thing. Now we will put 1 in this. Now for I is equal to cnt 1 to cnt 2, we will put 2 in this range. So from I is equal to cnt 1, from I is equal to cnt 1, I less than cnt 2. Okay, cnt plus I arr I is equal to 2. But these are the count, so we need to calculate the indexes from these count. So for 0 it will be 0 to count 0 because these are the number of zeros, and for reaching to count 1 we need to add count 0 to count 1. So here I have done one mistake. From I is equal to count 0 to I less than count 0 plus count 1, because these are the count not indexes. So for getting the indexes we need to sum up. So this will be the range of from count 0 to this will be count 0 plus count 1. From count 0 to count 0 plus count 1 we will be putting 1, and from count 0 plus and count 1, from here to here, what is this index? Suppose this index is r, and what is r? cnt 0 plus cnt 1 plus cnt 2. Oh, sorry, basically this sums up to n. So from up to r, up to n, up to n, from I less than n, and here from where we are starting from this range. Count 0 plus count n plus 1, count 0 plus count of 1. This will be the starting part. From this to this we will be storing n. So now again discuss about how time complexity big O of 2n can will come here. So for iterating loop, here we are getting time complexity of n, and again here in three parts we are getting the time complexity of n. So the time complexity of whole code will become 2n, basically n. So now we need one more we will solve this question by one more approach. And this is the famous question by the name of so third approach will be Dutch national flag algorithm. This question is known by this name, and this question can be solved by this algorithm. Sort an array of three colors can be solved by this algorithm. So what does this algorithm says? This algorithm says we have been given an array. So there will be three pointers: low, mid and high. So this algorithm says that from 0 to low, from 0 to low minus 1, between from 0 to low minus 1, 0 will appear. From low to, oh sorry, from low to mid minus 1, we will be putting 1. From high to, from high to n minus 1, we will be putting 2. And this middle part, and this middle part, and in this middle part, this will be unsorted. So basically this is sorted, this is sorted, and this is sorted. This will be unsorted part, so we need to sort this part as well. So this will be our approach of doing this. Basically 0 to low minus 1, we need to put 0. From low to mid minus 1, we will be putting 1. And from high to n minus 1, we will be putting 2. So we need to do these things. So let's take an example, and I will show you how this question, how this algorithm can be used for solving the question of sort an array. So our array is 0 1 1 0 1 2 1 2 triple 0. So this is our array. So this is our given array. Now solve this question. So let's take as you can see in the above question, above note, I have written we need 3 pointers for solving this question. So let's take 3 pointer. So here from 0 location, we are taking low and mid, and we will increase low and mid based on some condition. Here we will take here we can take high. So what I have said just before, from 0 to, from 0 to low minus 1, we need to put store 0. So here let us start iterating the array. Here it is 0, and before low we need to put all the zeros, and between low to mid we need to put 1. So when ARR, when this ARR, when the mid location has 0, we will increase our mid and low both pointers. So low will come here and mid will come. I am writing L instead of writing low, and instead of writing mid I am writing M. So now when mid and this has occur, when the ARR mid has 1, so we can see that before L we need to store all the zeros, and between L to M we need to store 1. So here L, here M. So by seeing that we need to increase only M, not L, because L to M we need to store 1. So now again 1 appears. So between low to M we need to store M. So it is already sorted. So just increase M. So now we can see at ARR M, ARR mid has 0. So our approach says that between L to M we need to put all 1, but now this 0 appears. And our algorithm also says that before L we need to put all the zeros. So what we can do, we can swap this 1 and 0. So by swapping 0, this 0 will come here and this 1 will go there. 0 1 1 1 2 1 2 and triple 0. So now we will be increasing our both pointer. L will come here, L, and M will, when here our mid is equal to 0, we will increase our both pointer. So M will come here, M will also increase. So now we can see that before L all are sorted. Before L we need to store 0, so this is our all 0 and this is already sorted. Between L to M we need to put all 1 and in the sorted manner, but here we can see that before between L and M, now here it comes 2 and this is a high pointer. So I will tell you what I am doing. When ARR mid is equal to 0, we will increasing two pointers L plus plus and M plus plus. When ARR mid is equal to 1, I am just increasing M plus plus because between L and M already sorted. That's why only this pointer. When A of mid is equal to 2, swipe A of mid, A of mid and A of high, and decrease high pointer and increase mid pointer. Okay, just one more thing here. Here we also need to swap what 0 and 1 means L and M. So now again come to the question example part. So now this 2 appears here and between L and M there is now become unsorted. So we will swap this 2 with the high pointer because 2 needs to go in the last. So now the our array will be 0 0 1 1 1 0 1 2 0 0 2. So RL was here, M was here, and we will decrease high pointer. We will decrease high pointer here. Oh, sorry. We need to swap the value, swap these values and the high pointer here. Only we need to decrease the high pointer. So now we will again check ARR mid. ARR mid is now 0. So again between L to M there is not only one, there between L to M there is no sorting. So we need to swap this and this because of the left of the L we need to put all zeros. So now again we will modify our array by swapping this value and this value 0 0 0 1 1 1 1 2 0 0 2. So now when we occur mid value 0, we will increase both L and M after swapping. So we have swapped here. Now we will increase L and again and we will increase M and high remains same as it is. Now A of M is equal to 1, do nothing because between L and M all are sorted already. So just increase the value of M. So now uh, A of M A of M is equal to 2. We need to first swap with the higher pointer and decrease the high pointer. Okay. So now uh, no no. So we will be swapping these two values. So our array will become 0 0 0 1 1 1 1 0 0 2 2. So we will decrease high from here to here. Our M remains same and L remains same. Now we will check between L and M there is sorted part or not. No, because there is 0, so this is not the sorted part. So now we will again check A of M is equal to 0. Yes, first we need to swap, then increase both the pointers. So we will swap this from the this part 0 0 0 0 1 1 1 1 0 2 2. So we will increase L and M and high. So now we will check A of M is 0. Yes, it is 0. So between L and M there is no sorting. So we will sort our array by swapping these two values. We will swap these values. So now array will become 0, 0, 0, 0 and one more 0, 1, 1, 1, 1, 2, 2 and we will increase L, M and H. So now we can see that our array gets sorted by these three pointers and we can see that we have only iterate our array only once. So the time complexity of this question will be big O of n. So now write the pseudocode of this question, this algorithm. For I is equal to, we need to take three pointers. Low, mid is equal to 0, high is equal to n minus 1, while mid less than or equal to high. Now we will check whether if ARR mid is equal to 0. If it is true, what we will do first, swap ARR low. I am writing L instead of low, ARR L and ARR mid. ARR low and ARR mid, and after that we will increase mid pointer as well as low pointer L pointer, and if ARR mid is equal to 1, then we need to do, then we will do nothing, just increase the mid pointer. If ARR mid is equal to 2, it means we need to swap it with the higher pointer because 2 will get placed in the last positions. So first of all we will swap it from the high pointer, and after that we will decrease the high pointer as it is, and so this is the code. But as we can see easily, we are only iterating our loop only once. So the time complexity of this code will be big O of n, and space complexity of big O of 1. Let me write clearly. Time complexity big O of n, space complexity big O of 1. So these are the complexity part. So let me revise what I have said. This is a question of sorting the values 0, 1, 2. There are three approaches. First one is the brute force approach. In this we will sort an array by using merge sort. The time complexity will be big O of n log n and space complexity of big O of n. This is the easiest part, just by sorting the array. So now our target is, we need to decrease this time complexity from n log n to n. So there is one more approach by counting all the values, or by counting how many times 0 appear, 1 appears and 2 appears in the array, and after that we will again iterate our loop, again iterate our array, and we will put number of put a 0, 1, 2 based on their count which we have done earlier. And the famous algorithm, Dutch national flag algorithm, can be used for solving this question. In this, before we will take three pointers, low, mid and high, and from 0 to low minus 1, basically it says that before low all 0 will be there, between low to mid minus 1 all 1 will be there, and from high to n minus 1 all will be 2. So basically these three part will be sorted, and the mid minus 1, this mid minus 1 to high, sorry, mid to high minus 1, this part will be unsorted. So this part will be unsorted. So we will iterate the entire array once, and will swap values based on these conditions which I have written here. So this is these three are the approaches for solving this question. Okay, thank you.